In this video, we're going to explain the difference between the rotational speed, or RPM, and the tip speed of a mixer, and why the tip speed of the rotor is the more important factor to consider with high shear mixers. In simple terms, the RPM relates to how fast the motor and mixer shaft is rotating, while the tip speed is a measure of the distance travelled in a set time by a point on the periphery of the rotor. So with a constant RPM, the larger the rotor, the higher the tip speed. The reason the tip speed is the critical factor with a high shear mixer is all down to how the shearing action is created. Remember that a simple definition of shear is the cut. It's the rotor sweeping past the stator and forcing the product out through the holes in the stator that creates the cutting or shearing action. That's why tip speed will form the basis of the calculations for a mixer's shear rate, the number of shearing actions per second. This is important to consider when scaling up from the laboratory to production mixers. Some people assume that because they ran their lab mixer at 10,000 RPM, they need a production mixer that runs at the same RPM. Conversely, others think running their lab mixer at the same speed as production models will replicate the performance of the larger scale mixer. But because the mixer's ability to disintegrate solids, or reduce globule size to form an emulsion, is determined by the shear rate, to obtain comparable results when scaling up, you need to consider the tip speed, not the RPM.